Okay, I'm going to talk a little bit about sampling. Basically, there's nothing really to be done at this point about sampling other than watch this video here. That's the one you saw before. You might want to look at it. It gives you a pretty good overview of inference, and it talks about sampling. The idea here is that it's very important because we're going to be doing a sample, and we have to talk about that sample as to how good it is, how reliable it is, around making a judgment about what's going on back in the population. So how we take the sample is important, and a bunch of features about the sample are very important. And why do we sample? I mean, let's talk about that. So what is a sample, first of all? It's just a random selection of individuals from a population. And it should be large enough to be a good sample of what's going on. It should be representative of what's going on in the population. And what we do is we use the statistical parameters of the sample to help us decide or make an inference about what's going on back in the population. Now, an inference just means make a decision about, or an assumption, or some sort of intelligent kind of speculation about what's going on back in the population based on the sample. So the better your sample is, the more reliable your statistics that you get, and the better your inference will be back to the population. So parameters, when we use the word parameters, we're basically talking about things like the median, height, or median weight, or the mean of something, or the interquartile range of the middle 50% or whatever. So you could be talking about heights, or age, or social economic status, or salary, or whatever it happens to be. And you'll be talking about the averages of those and other things. And remember, we're going to be doing box and whisker plots, and so that's what we're going to be using as our statistical graphs, and our visualizations will come from that, whereas in time series we used obviously time series graphs. Why do we sample? It's because it's easier, it's quicker, it's cheaper than looking at a whole population. I mean, we do a census in New Zealand, and every country basically does a census of the entire population. Well, that's a very expensive, time-consuming endeavor. It's much, much easier and much quicker to do a sample. And done properly, that sample can give us a good idea about what's going on back in the population. So, just to sort of summarize that, the sample statistics that we get, like the mean or of a bunch of little critters here, our minions, if you get the mean weight or the mean height or whatever, we can find that specific statistic. We can take a bunch of these guys and sample them and then find out what their average heights are. What we don't often know is we don't often know what the population parameters are at all. They're unknown. So we'll use the sample statistics to sort of make an inference back to what's going on in the population. So we use the sample statistics to make assumptions about the population. So the first bit of this, which is using the sample statistics, looking at the box and whisker plot, doing talking about how we compare the shapes and the shifts and where the middle 50% of the data is. This was all done in year 12 in inference. So if you did inference in year 12, you would have a fairly good background about what's going on in sample statistics. What you haven't done is the inference things, and so that will be the new stuff that we will get to. Now, the other very important part of sampling is that there's different ways that we can do sampling, and I want you to look at this New Zealand grapher sampling a data set, because this is quite useful for giving you an idea of how to sample and what it looks like when we do it in New Zealand grapher. So have a look at that video. But there's different types of sampling methods. You don't need to spend a great deal of time on it, but you have the simple random sample, which is done a lot, and it's very convenient. You just sort of do some sort of random number thing, and you pull out a certain number that's affiliated with somebody, and you sample that way, just through a random number sampler. So, everybody's assigned a number, and then you randomly select a 10, and that person gets picked out of the population to be in your sample. And it's random, which is what we're looking for. A sample has to be random, so everybody sort of has an equal chance of being selected. There's other types of sampling techniques like cluster sampling, systematic, and stratified sampling. And down here in this little box, it kind of gives you a a sort of a summary of what that sampling method is about. And it's very, very important that this whole idea of representative. Now, a representative sample basically means that the sample represents the population. So if you have a certain proportion of males and females in your population, your sample should represent that same type of proportion. If you've got a certain proportion of Maori in your sample, then it has to reflect that. So it has to be a representative sample. Simple random samplings is a good convenient way of doing it from the whole population, and it's easy. It's generally unbiased as the whole population covered, but it's difficult if you have a large population, because if you've got a large population, then it becomes difficult to get a random sample from that in a convenient way. There's systematic sampling at regular intervals for the whole population. It's not particularly hard, it's unbiased, but again, it's a bit difficult if you have a large population, and maybe biased if there's a population pattern sort of thing going on. Stratified sampling is really good because it allows you to get a good proportion. So again, if you have like 40% of females and 60% are males in your population, then you want your sample to represent that. And so stratified sampling allows you to get that proper proportion. So it samples from groups in a population in proportion. And this video up here does a really good job of talking about that kind of that kind of sampling. So groups in the population represented in proportion to group size, just a little bit more difficult to organize. And then there's cluster sampling and so on. So you just need a little bit of understanding about those different methods. You need to have a look at this video, and it sort of gives you a kind of a good idea of how stratified sampling works, and it's just good to have a little bit of information under your tool belt. Now, why is it important about the way we sample and the mechanisms for sampling is about this whole idea of bias. And we've talked about this in time series a little bit. If your method of sampling has some elements of the population more or less likely to be chosen than others, you have a biased sample. So, if we used St. Cuthbert's as an example of year 13 students, and we did some sort of a survey or whatever about from those year 13 students, we have a very biased sample because it's only girls. It's not boys. We're only sampling and surveying girls, and then we're saying, well, this is what's going on back in the in the population of year 13s, and it's not accurate because it doesn't represent the entire population, and because boys have not had an equal likely chance of being chosen to be in that survey. So you have bias. Bias is bad. You want everyone to be equally likely to be chosen in your sample, and you want your sample to be representative of what's going on in the population. So again, we've talked about this before, but if you do a phone survey of 18-year-olds, you have developed bias in your sampling technique because not everyone has a landline, and so not everyone's going to be phoned into that survey. Phone a home parent most likely to answer the phone, and so you might not actually even get an 18-year-old to answer the phone in that particular circumstance. So that's bias. So how you take your sample is very important, and you're going to have to be aware of in your internal of how the sample was taken, how the data was collected, and you may have to have a conversation about whether it was a good technique, if it built in any kind of bias into the sample itself. So again, we talk about why we sample. It's easier to deal with a sample than a whole population. It saves us time, cost. It's a little bit easier to do. Accessibility. What must it do? It needs to minimize bias, and it must be representative of the population. So what does representative mean? We've talked about this before. Oops, that's not going to work very well. But basically means a sample reflects what's going on in the population. So the various characteristics of a population, which we call demographics, right? They're being represented in this group. So the ethnicity, the economic status, the employment of people, the age, their marriage status, their gender, and so on, sexual orientation, whatever. This is all your demographics, right? That's what we're talking about when we talk about demographics. So you need a sample that represents your population. And if you can ensure that those kinds of things are happening, then you've got probably a good sample.